Okay, so the last question for the week 4 tutorial is going to be about a truck that have a box sitting in the back. So let's read the question step by step and see what do we have here. So we have a trailer portion of a truck has a mass of 4,000 kilograms. Well, 4 million grams is 4,000 kilograms with a center of mass at the point G. So that's the center of the mass for the truck trailer portion. Uh, if the uniform crate having the mass of 800 kilograms and center of the mass at the GC, that's the box we have here, the center is going to be in the middle of it. Rests on the trailer, they remind the horizontal and the vertical components of the reaction at the ball and the socket, which is going to be at the point A, when the truck is going to be decelerating at a constant rate of the acceleration of 3 meter per second square. Remember that this will be deceleration, that means it's going to be slowing down, and that means it's going to be negative. We're going to assume that the crate does not slip on the trailer and neglect the mass of the wheels, and the wheels at B are going to be rolled freely. That means we are going to have reactions on vertically on the A, vertically at the B, these weights going downward, and we're going to reaction on the X at the point A. On the kinetic diagram, we're going to have the two masses multiplied by the acceleration. So you can see that the free body diagram has been sketched here and the kinetic diagram next to it to the right. And we're going to solve for the X and the moment, and we're going to find the value for the AX and the AY. We ignored the equation for the forces in the y direction because it's going to include the MB. That's something we don't want to involve in calculating. So first we're going to define that, consider that the trailer and the crate is going to be one system. The mass center of the system may be worked out first, then calculate about using the equation that we mentioned earlier. But the above is going to be unnecessary, and we can simply use the mass center of the trailer and the crate individually and do the calculation. So you can see here that I simplified the free body diagram from the complicated shape to this one. I ignored putting the dimensions, but you can tell that the GT is going to be, well, for the truck is going to be 1.5 meter above the ground. The GC is going to be 1.75 because 1.25 plus 0.5, 1.75 from the ground. And the point, and it's going to be horizontally about 2.5 meters from the point B horizontally, while this one is going to be 4 meter away from the point B horizontally, and the force A is going to be 8 meters away from the point B horizontally, and the AX is above the ground by 1.75. On the other side, we're going to have the masses multiplied by the acceleration. We don't have moment, we don't have vertical forces. So it's only going to be about the horizontal forces that we can get from the value of the mass multiplied by the deceleration value of 3 meter per second. So now we have the unknown is the mass of the trailer and the mass of the carriage, and we know that the acceleration at the 2 points, the GT and the acceleration of the GC is going to be 3 meter per second square. The unknowns are going to be the reaction forces at the point A, X and the Y direction, and also the MB if we need to calculate it. We don't need it because it's not given to us, but we can do it. So first, the equation is going to be for the forces to the x-axis, forces to the y-axis, and the moment around the point B. Okay, we're taking this point. Now, clearly, I can say that the first equation here, the forces to the x-axis is going to be the AX for the free body diagram, and here we're going to have the MTAGT plus the MCAGC. We know the masses, we know the acceleration, the AX can be found now. So this was the first step, and that's what we've done here. Okay, so in the free body diagram is just the reaction AX. In the kinetic diagram, we're going to have the masses multiplied by the acceleration. So that simple step, just put the figures in, And we're going to get that the AX is going to be equal to 14,400 Newton. We put negative because it's going to opposing the direction of the trailer. Now we're going to the other side. We got negative as well because we have this direction here. So this will be -3 and -3. Now for the forces to the y direction, I just put the equation. We don't need it anyway. So it's going to be the AY upward, the MB upward, the weight downward, the second weight downward. Okay, so these are negative, negative, positive, positive. Then I'm going to have a relation between the AY and the MB. On the kinetic diagram is 0, so I'm going to put 0. Now, that's the equation we're going to have, the relation between the AY and the MB. As I said once again, we don't need to do this one now, but we can use it later. Okay, if we are going to require to find the MB. If I'm going to find the AY from the next step, the MB can be calculated directly. Now, the last step and the last hope we're going to have is making the moment calculation. And this moment we are going to have is, now you can see that this force and that force are unknown. So again, to put the rotation around that point for the moment, we can see that we do have moment on the kinetic diagram, and we have moment on the free body diagram. And that's explained here. Take the moment around the B as the point P, the center of the rotation, and we're going to have the moment in the free body diagram is going to be equal to the moment in the kinetic diagram. I'm not going to show you the equation here. I will go back to the previous slide, and I'm going to show you actually how to calculate every component for the moment. So now we have we'll start with the x forces. So we're going to have the AX, which is 1.75 above the point B. So the first part is going to be the AX multiplied by 1.75. This is going to take the moment to the clockwise direction, so this will have a negative sign. The AY multiplied by the A meter, which is the horizontal distance perpendicular to the AY. Okay, so this will be negative because it's going to take the moment to the clockwise direction. Now we're coming to the WT. So WT is perpendicular to the distance of 4 meters. So we have here negative, negative. We're going to have this one multiplied by 4 meters is going to be positive. And this one multiplied by the 2.5 meter distance is going to be also positive because this is going to take the moment to the counterclockwise direction. And that's what makes them positive. Now we go to the kinetic diagram. We have the MTAGT is about 1.5 meter above the horizontal. So this force multiplied by that is going to take it to the clockwise, so it'll get to be negative. And this one multiplied by 1.75, again, is going to be negative. So that's what we have on the kinetic diagram, and that's what we have on the static diagram. So the equation now is going to be written as following, and we can substitute the values. So you can see that the AX multiplied by 1.75 negative because clockwise, AY multiplied by 8 negative because it's clockwise, 4,000 multiplied by 9.81, that's to make the mass as a force, and multiplied by 4, and that will be this force multiplied by that distance, counterclockwise, so it's going to be positive. The 800 multiplied by the 2.5 multiplied by 9.81, again, is going to be positive because it's going to go to the counterclockwise. Now, we finish with the free body diagram moment. We go into the kinetic diagram moment. Is going to be the 4,000 multiplied by 1.5. Okay, 4,000 multiplied by the 1.5 multiplied by the acceleration. We put it negative because we're going to turn the things to the clockwise direction. And then the 1.75 multiplied by 800 multiplied by 3, also negative because it's going to go to the clockwise direction. Now, the only unknowns we have here is going to be the AY because we already did found the AX, which is 14,400, as you remember. So by substituting all the parameters in, we're going to end up with this equation, and we end up with the AY to be equal to 20,700 Newton upward, and that's it. Now we can substitute that in the other equation that we found in the previous page, or the sigma of the forces to the y direction equal to 0, and we can find the value for the NB. That's it. That's it. So it's quite simple question, though it's look complicated. But once again, you don't judge the question from the how the free how the diagram is look like. Just try to make the free body diagram and the kinetic diagram, and this will give you a better look for the question and how to make a good analysis for that question. Okay, thank you very much, and we're going to see you once again in the week 5 questions very